Well, hello everybody. My name is Pablo Marin. It doesn't work? I don't know. Okay, now it's better. Thank you. So, hello everybody. My name is Pablo Marin. I come from 7 Solutions. First of all, I would like to thank Marubun for inviting us here to present you and introduce you to our technology, White Rabbit. And today we are going to explain you how it works, how the synchronization works, which applications it has, and some products we have available. Okay, so 7 Solutions, for those who don't know already, it's a privately held company, leader in accurate sub-nanosecond time transfer and frequency distribution for reliable industrial and scientific application. We have more than 10 years of expertise in different sectors as avionics, telecommunications, smart grid, military, space, and scientific facilities as particle accelerators and radio telescopes. We have more than 7 years of expertise accurately synchronizing distributed instrumentation facilities and data centers with White Rabbit. So what it is, White Rabbit? It's basically, it is a technology that was born at CERN, the particle accelerator in Geneva, in Switzerland. And it's brought by industry by 7 Solutions for general purpose long distance link and long data transfer and sub-nanosecond accuracy synchronization. What it is about? Well, basically, White Rabbit is a mix of synchronous Ethernet and PTP. But it has some modifications that allow us to achieve sub-nanosecond accuracy. On paper, it's basically recovering the frequency thanks to synchronous Ethernet, changing messages as PTP does, and then there is some dynamic calibration, dynamic exchange of information, and dynamic phase adjusting to allow us to reach that level. So what the synchronization is done by these 2 techniques, and this allow us to have accurate timestamps, have thousands of nodes thanks to that is based on Ethernet, distance range over 80 kilometers in one hop with the standard SFPs that we are using, robustness and redundancy as we can have the same techniques as are using Ethernet networks. And what is most important is dynamically calibrated. You don't have to worry about link calibration the way you do with PTP, in which you have to spend time on each and every link to account for asymmetries, delays, and then your network change, you have to recalibrate again. With White Rabbit, you don't have to worry about all that. It's done automatically. So thanks to its synchronization, you will have a common notion of time of your entire network. And the sub-nanosecond synchronization is achieved in parallel and transparallel to data exchange. But this is most important. The data exchange doesn't impact the time in performance. Actually, it benefits because thanks to the data exchange, the clock is recovered from the same frames, Ethernet frames, and then the clock will have a better information. So you will have better phase alignment than if you don't have data. Then 2 main technologies are used together for this: synchronous Ethernet, as I have been mentioning, and enhanced PTP. This enhanced PTP is the standard PTP we know, and some more message exchange that allow us to align the slave clocks to the master clock, measuring the delay between the master and the slave thanks to the phase measurement offset. So first of all, there is a synchronization done via synchronous Ethernet that eliminates the little errors that are between the individual clocks in the network. Some of them are a little bit off, so thanks to synchronous Ethernet, the frequency of the master is transferred into the data, and the slaves can recover them and chain its local oscillator accordingly to the masters. So every device at the end on the network will share the same frequency as the master has. But this is not additionally to the synchronization and the frequency. Once we have all the devices with the same frequency, we need to share the phase, the moment in which the frames start and the seconds start, to be all of them to be the same. For this, there is a specific hardware that is measuring the phase offset live and in every moment the phase between the master and the slave with a precision of sub-picosecond. and there is a loop that is accordingly adjusting the local oscillator on the slave for that.